Okay, last learning target of the integumentary system. Learning target 11, I can describe how the skin may deviate from homeostasis in the human body. So remember, homeostasis, maintaining stable conditions. So what happens if our skin gets out of homeostasis? So the first thing we talk about is body temperature. This is a big one. We discuss a lot with homeostasis. How does skin play a role of that? Well, it's a huge role that the skin is going to play. The reactions of the body work at a certain rate, as you can see there in bullet point 1. So we have to maintain certain body temperatures for those things to happen. Okay, we know that it's going to take place at about 98.6 degrees Fahrenheit. So what do we do? How do we get those conditions to stay stable? So I'm looking at bullet point 4 here. It says if the body heat goes above a set point, meaning that we're getting too hot. You're out in the summer and you're running and it's just hot and your body's overheating, what's going to happen? Well, that's going to be a negative feedback control loop, which goes all the way back to unit 1. But what's going to happen is warm blood is going to be carried to the center of the brain called the hypothalamus. When that happens, it says dermal blood vessels. This is all just a chain reaction. Dermal blood vessels are signaled to relax. So we get vasodilation. So the blood vessels in the dermis open up. When they open up, when they vasodilate, the blood is going to enter those blood vessels. So blood is being rushed to the surface of the skin, and that allows heat to be released at the surface of the skin. That's why we get that erythema, and the blood, your skin starts to look a little red because blood is rushing there. The blood vessels that are deep are going to vasoconstrict. Vasoconstriction meaning they're closing up. So if they're closing up, they're pushing all the blood away from them. So the deep blood vessels are constricting. The superficial blood vessels are relaxing. So and that blood is carrying heat with it. When it carries heat, it's taking it to the outer portion of our body, the superficial portion of our body, and that allows us to release heat. There's a few different ways we release heat this way. You can go back to physical science and talk about conduction and convection and radiation, same thing. But another big one is evaporation. So we're going to stimulate our sweat glands. Our sweat glands are going to produce sweat. And when they do that, it is going to evaporate. And that evaporation of the sweat is actually going to carry heat away from us when we feel hot. Now, the flip side of this, not necessarily flip side, the problem with this is what if I'm in a humid environment? So humidity is that moisture in the air. If there's a lot of moisture in the air, it makes it harder for our sweat to evaporate. So if our sweat can't evaporate as fast, that means we're going to feel hotter. So I'm sure you've heard people talk about how they feel worse or it feels sticky on a hot, humid day. That's because the sweat is not evaporating quickly enough. If our body temperature goes below a set point, okay, so now we're going the opposite direction, we're getting cold, well, let's go, everything happens in the opposite way. So the blood vessels at the surface are going to vasoconstrict, and the blood vessels that are deep, closer to our internal organs, are going to vasodilate, okay? So now when we do that, we push all the blood away from our surface and send it to our internal organs. Both of these mechanisms, when you're hot or when you're cold, the most important thing to keep at stable internal conditions are the internal organs, because you got to think about it. Those things are kind of important, right? Our heart, our stomach, our liver, our gallbladder, our intestines, our brain. We don't want them fluctuating their temperature. Our skin is actually able to fluctuate a little bit. It's going to get hotter and colder, but we want to keep those things internally really stable. So again, back to if I start to get too cold, the blood our blood starts to leave our skin and is pushed towards the center of our body or the core of our body. So now the blood vessels at the core of our body are vasodilating. We are inactivating our sweat glands, and we'll probably start to shiver. That's our muscles, and a lot of times those could be dermal muscles, are going to start contracting rhythmically to try to generate some heat. Two temperature regulation terms here, hyperthermia and hypothermia. Hyperthermia is when the body heat temperature rises too high. That is a bad thing. So You might have heard of heat exhaustion or heat stroke, so that could be a cause of hyperthermia. Hypothermia is when you start to get too cold. Now our body temperature is decreasing, so somebody's caught out in the cold. An elderly person who might not have as much body fat, young children or homeless people are really at risk of hypothermia. Just a drop of a few degrees can really be a big deal if hypothermia is set in. The other way that the skin goes out of homeostasis is burns. So there's few different types of burns that you could be subject to, and they're all basically are different by the depth at which they go. So anytime you're exposed to heat, maybe you've touched something hot, maybe you've spilled something hot on you, or it could just be a sunburn, we're looking at different types of burns. So the first category we have are partial thickness burns. Those are first degree and second degree burns. First degree burns only affect the epidermis. This is just where we get a redness, pain, maybe a little bit of swelling at the epidermis. This is mainly, most of the time, it's just a sunburn or a really slight burn from a hot object, and it's going to heal pretty quickly. Second degree burn is going to damage the epidermis and the dermis. However, it's not going to go all the way through the dermis. So we're going to really get all the way through the epidermis. It's going to be a lot more painful, a lot more swelling and inflammation and edema, which is that swelling in the area from fluids. And you could see blisters forming here. So these burns are a little bit more significant. Contact with hot objects, maybe you stuck your hand on a stove, maybe you touched a flame, something like that. And it's going to take a long time to heal. Our last type burn are called full thickness burns, and these are third degree burns. Think of full thickness, we're getting all the way through the skin, so this is when the epidermis and dermis are totally destroyed and could possibly damage the subcutaneous layers underneath. This happens when you are submersed in a hot liquid or it's prolonged exposure to a fire, to flames, to hot objects, something like that, or it could just be something corrosive like an acid or a strong base. When you have a third degree burn, it's basically damaging everything. So it's damaging not only the skin, but also the accessory organs. So you may lose the ability to grow hair. You may not have pain in that area because you've damaged the sensory receptors and you've really gone all the way through the skin. And this is where you're going to need to get skin grafts or something to try to replace it. With a third degree burn, like I just said, sometimes parts of them will grow back, but you're probably going to need to get skin grafts or skin substitutes. There's a couple different kinds. First, they're called split skin grafts or autografts. This is when you take a part of the skin from your own body and replace the burned area. So, you're getting that donor from your own skin. Homografts you get from maybe human cadavers or from person to person. The problem with this is the body can reject them pretty easily. And then finally, healthy skin can be grown in a lab, and we watched a little movie about that early in the year. But unfortunately, when you do that, we're just kind of getting the epidermis. We're not getting a replacement of the glands, the hair, the sensory receptors, things like that. A couple of rough pictures. This would be a first degree burn. That's a sunburn. This would be a second degree burn. You see the blistering. You see some of that edema and that fluid leaking out. This is getting into the third degree burn. See how it's a really bad burn. Notice that the third degree burn, the really bad areas, are also surrounded by second degree burns in the other areas that don't look quite as bad. Just a little diagram of what you see, and then, man, you got to feel the burn. That's it for the integumentary system.